The starter motor. It's the real unsung hero that brings your car to life.
So let's just start with this question. You turn a key or you push a button, right? And this massive, multi-ton engine just roars to life. How does that tiny, simple little action overcome such an immense amount of physical resistance?
Well, the answer lies in this compact powerhouse, the starter motor. It is an incredible piece of engineering designed to do one thing really, really well: convert electrical energy from your battery into the raw mechanical force needed to crank that engine from a dead stop. And let's not underestimate the challenge here, because this is a big one. A starter has to do way more than just spin a fan. It has to overcome the engine's internal friction, its sheer inertia, and, this is the big one, the massive resistance from compressing air inside the cylinders just to get it moving at all. Okay, so let's dive into how it pulls this off. The very first piece of the puzzle is a component called the solenoid. You can think of it as the starter's brain and its muscle, all rolled into one. It acts as both a smart switch and a mechanical actuator.
So why is the solenoid so crucial? Well, look at it this way. Your ignition switch, the thing your key goes into, is only designed to handle a very small electrical current. But the starter motor? Oh, that thing is a power-hungry beast. It demands a massive amount of current, so much in fact that it would literally melt your ignition switch and all its wiring in an instant.
The solenoid is the clever solution to this problem. It's basically an electromagnet that acts as a heavy-duty relay. See, that small, safe current from your key energizes the solenoid, which then closes a completely separate, much larger circuit that's capable of handling that huge rush of current from the battery to the motor. And here's the really cool part. When you turn that key, the energized solenoid does two things at the exact same time. First, its internal plunger shoots out, moving a lever that physically pushes a small gear, called the pinion, forward to mesh with the engine's flywheel. And second, at that same moment, it slams that high-power circuit shut, allowing the battery to finally unleash its power on the motor.
All right, so the main circuit is now complete. What happens next? A massive flow of current from the battery floods into the starter motor, and this is where its raw power gets unleashed.
So this huge current travels through a set of brushes and into coils of wire in the motor's rotating core, which is known as the armature. This creates a really powerful magnetic field that then interacts with magnets in the motor's housing, and that interaction forces the armature to spin with incredible speed and force.
But here's the thing. All that high speed isn't enough on its own to turn over a heavy engine. The real magic, the secret sauce to the starter's strength, is how it multiplies its torque. And it does that using some simple, absolutely brilliant mechanics: gears.
First, you've got that small pinion gear we talked about. It meshes with the engine's huge flywheel. And just that size difference alone provides a gear ratio of about 15:1. That instantly multiplies the motor's turning force 15 times over. Pretty cool, right?
But for most modern engines, believe it or not, even that's not enough. So a lot of starters today include an internal planetary gear set. This gives it another layer of gear reduction, often adding another 7:1 ratio right into the mix. So when you combine them, you get this massive total gear reduction of over 100:1. This is exactly how the starter transforms the motor's fast, relatively weak spin into a slow, incredibly powerful crank that is more than strong enough to force that entire engine into motion.
So the engine is running, it's taken over, fantastic. But this actually creates a new and very dangerous problem for our hardworking little starter motor. See, once the engine ignites, it immediately starts spinning at hundreds then thousands of RPMs. That's way faster than the starter motor was ever designed to go. So what's stopping the engine from spinning the starter motor so fast that it literally tears itself apart? The solution is another ingenious device called an overrunning clutch. You can basically think of it as a one-way door for mechanical power. It allows force to go in one direction, but it will not let it come back the other way.
This clutch uses these small internal rollers. Now, when the starter is cranking the engine, these rollers wedge themselves into place, locking the clutch and transferring all that power. But the instant the engine starts spinning faster, that backward force releases the rollers, which allows the gear to just spin freely, protecting the motor from what would otherwise be a catastrophic failure. So now that you know exactly how it all works, from the solenoid to the motor to the gears to the clutch, here's the big takeaway for you. Understanding this whole process can actually help you diagnose a problem with your own car. You just have to listen. For instance, if you hear a single, loud click but no cranking, that's probably the solenoid failing to close the main circuit.
A harsh grinding noise? That could mean the pinion gear's teeth aren't meshing correctly with the flywheel. If you get that slow, labored cranking, that often points to a weak battery or just a bad connection. And if you get nothing at all, well, it could be worn-out motor brushes or a complete failure.
You know, for over a century, this elegant solution of solenoids and motors and gears has been an absolutely essential part of nearly every single car on the road. But as we start moving towards an electric future, where the main drive motor can also spin the engine in a hybrid, or where there's no engine at all, it leaves us with one final thought. Is this brilliant, essential device that we all rely on destined to become a museum piece?